Hi, I have another question here on further differentiation. Um, and this one goes by you have got a function or an equation or a curve equals to y equals to 2, y equals to sine 2x plus 3 cos 2x, and then x is in the interval between 0 and pi radians. Now here's a quick sketch of it. They say at this points Q and the point P, the gradient of the curve is 3. So that means dy at this point here, dy dx is equal to 3. Similarly, also at this point, dy dx is equal to 3. As that information is given to us, they say the gradient of the curve at the points P and Q is equal to that. So, of course, here they give you an indication. We need to find dy dx. So let's find dy dx. And if you do so, you're going to obviously, let me just write down the equation. This is y equals to the sine of 2x plus 3 times the cosine of 2x. Right. Then dy dx, you can do separately. So dy dx is equal to, in this case, I think you should be familiar as to how to find the derivative of sine function, which is nothing but the cosine of 2x, and that multiplied by the inside function of 2x, which is just going to be 2, and then plus 3 times the derivative of cosine is minus sine of 2x, and then should multiply by the 2x inside the derivative of 2x, which just happens to be 2. Okay, at this point I do expect you to know how to derive trig functions. So let's just clean this up a bit. So that's going to be 2 cosine of 2x, and then you have a negative here, and 3 times 2, that is negative 6 sine of 2x. All right, so that is the derivative function as far as that one is concerned. That is dy dx that we were supposed to calculate. Okay, right. So there must be a b part to the question. So the b part say by first expressing dy dx in the form r equals to, now I did the question on how to use the R formula. So they want us to express dy dx. Let's just quickly write down what was my dy. My dy dx from before, dy dx is 2 cosine of 2x. That is 2 cosine of 2x minus 6 sine of 2x, if I can remember well. Let's just make sure of that. So that is that. Okay, so they say this should equal to, now this should equal to, um, they're saying, let me just change the color here. So they're saying that 2 cos of 2x minus 6 sine of 2x, this should be written in the form r cos of 2x plus alpha. Then alpha is an acute angle because alpha is an angle between 0 and half pi radians, that is 0 and 90 degrees. Then we need to find the x-coordinate of P and Q, and we are supposed to give our answers correct to 3 significant figures. Okay, so I think we will be able to, judging from the previous video, I just uploaded a video on how to find R. So I hope that you should know how to find R. So R is equal to the square root of the constants that you have. That's 2 squared plus negative 6 squared. All right, that is the value of R. So that is going to be 4 plus 36, which is the square root of 40. Now 40 in itself can be written as 10 times 4 or 4 times 10. So that's 4 times 10, that is the square root of 40, which can be separated as square root of 4 times the square root of 10. So this is 2 square root of 10. Of course, you can just use a calculator. Another thing that we know is we know how to find our alpha. And hopefully you still remember that our alpha will be the inverse tangent of, so it has to be tan sine over, so it must be and that's 6 over 2, so it will be 6 over 2, which is just 3, right? So we can grab a calculator, and it's very important here that you notice that we are working with radians, so you should definitely change your calculator to radian mode. Okay, so inverse tangent of 6 divided by 2, that's just 3. Okay, so this is the you just grab that answer. Okay, so this is our answer over there. Okay, now what is it that they are telling us now? We should write it in that form. So let's write it in that form. So our R is this, so that is 2 root 10 cos of 2x plus, well, I'm just going to write this. They're saying you must write it to 4 significant figures. I'm just going to write as 249045, for example. And that should equal to something. So they gave us definitely what it equals to. Now we are told that that should equal to 3. Remember, we are saying that the gradient dy dx is equal to 3 at the various points. Okay, so we're going to let that equal to 3. I'm going to say that should equal to 3. So basically, what is it that we have over here? We have over here a condition where we took our gradient function and we just rewrote it into this form, right? So that means at the various points P and Q, that should equal to 3. Okay, because they say find the x coordinates of P and Q. All right, and at P and Q, the gradient dy dx is equal to 3. Okay, so let's just clean this up. This is going to leave me with the cosine of all of that, 2x plus 1.2490, for example. That is going to be 3 over 2 root 10. I'm not going to rationalize the denominator. Okay, you can if you want to, right? But I'm not going to go all ahead and do that. So we have to consider two possibilities here. The question says that we have to express that, find the x coordinates, and our alpha is obviously the 1.2. So we know from this that our answer should be in the first quadrant as well as in the second quadrant. Okay, first quadrant as well as in the second quadrant. But I'm looking at what is happening. They're saying the diagram shows the curve with the equation. So this curve is just from 0 to pi radians. That's what it's just a part of it. Okay, and then they're saying the value of r, we know what it is now, and alpha, we have alpha, and find the x coordinates of point P and Q. Right, again, as I said, the cosine is positive in the first quadrant as well as in the fourth quadrant. So I'm just going to let this 2x plus 1.2490 business be equal to k. So that's like cos of k is equal to 3 over 2 root 10. This in turn will tell me that cosine, that the inverse cosine or the inverse cos or arc or cos arc or arc cos, that is going to be that. So we can actually calculate what that is, okay, as an acute basic angle. Again, as I was saying, make sure your calculator is in radian mode. So inverse cos of 3 upon 2 root 10. Okay, you hit enter. Oopsie, let's make sure we go out of that. You hit enter, you get like this particular angle over here. So I'm just going to write that answer here. Okay, so that's what that answer is. Now in the first quadrant, so in the first quadrant, I'm going to say that whole thing of 2x minus, or was it 2x plus 1.24, 1.249045, and so on and so on. remember from here, that should equal to, this is the first quadrant, what I have over here, 1.07658, and so on and so on and so on, radians. Of course, x would be, to take the difference of those two, and you're going to divide that answer. And if I do that, I'm going to get negative 0.08623, and this is the x coordinate at point P. Okay, diagram might be slightly out. The x coordinate at point P. And then if you look at your fourth quadrant, you have got the fourth quadrant, you have got 2x plus 1.249045 and so on. At the fourth quadrant, it's going to be 2 pi radians minus 1.07658 radians. Of course, what you're going to do is you're going to find the difference of that, and then you're going to subtract 1.24 from all of that. That gives you 1.9788 radians. And this is the x coordinate, at what is it, at Q. Right. Now I have a little slight difference, of course, as to looking at a diagram, and looking at this diagram, then obviously x coordinates cannot be negative, okay, because the x, we are now talking about the first quadrant, because it's from 0 to pi radians. So again, so looking at that, that should be slightly more, that should be slightly positive value over there. Okay, all right, that should be a positive value over there. Okay, you can obviously see if you agree with me as far as that answer is concerned. All right. Okay, so I'm going to have a look at parametric equations, and also I'm going to look at the further trigonometric equations using obviously our formula from past question papers.